Hey, good evening, everybody. My name is Sudhindra, and I'm part of Hewlett Packard. I have my colleagues Arun, NR, and Aditya Vaja. So, this is a short disclaimer. So basically, today I'm here to talk about our experience in the field, deploying OpenStack and NFV solutions for quite a few telco customers across various regions, from APJ to EMEA to Europe to Americas. So actually had a demo ready. We did have the use cases ready to demo, but unfortunately, we didn't know that we cannot use our laptop here. We had to use one of the session laptops, so sorry about it. But I'm going to talk about each of those use cases, and we'll just run you through what we have done. So basically, I don't have a PPT. So just before we get onto the experience, probably less than 1 minute or 2 minutes, I'll just quickly tell you what we do and who we are. I'm part of an organization within HP called as Global Solutions Engineering and Architecture. We actually are spread across various places. We also have virtual team in few countries. We actually work in Korea, in Japan. Most of us are in India, and then quite a few of them are in Americas, and a very small number in Europe. So typically what we do is we actually get engaged in pre-sales engagements, do proof of concepts. We build customizations on top of product whenever customer asks for specific requirement which is not available out of the box as part of the product. We do build on top of the product and actually demonstrate it as a viable or a feasible solutions what HP can offer. That's where our team brings in value add to the HP product team. So we do demonstrations, we do workshop assessments, we do proof of concepts on various products. A few areas of expertise is HP cloud system, HP software products, and in the last 2.5 years we've been working on OpenStack, a suite of products, mostly on vanilla OpenStack as well as HP Helion OpenStack and Chef and Puppet tools. So our experience on OpenStack, just to tell, we've been doing onboarding, VNF onboarding onto HP Helion platform for the top 5 network equipment providers across the regions, and of course we've been working with the top 25 telco customers. So I'm just not putting the names here, but it's quite obvious who are the top 5 and probably who are the top 10 telco customers. All these things are the POCs that we have done. Most of them are the customer side. A few of them have been done in HP in various NFV labs or the HP OpenStack labs that we have in various regions. So our core strengths on the OpenStack is all the core OpenStack services in terms of deployment configuration, and also various SDN controllers that we have been working with in the last 7 months. So that's about my presentation, what I had, and this is what actually I wanted to show in today's session. So we will run through each one of this use case one by one. So HP actually has a Carrier Grade version available in the market that's specifically meant for telco customers. So typically when we started doing OpenStack POCs sometime in last September, the kind of requirements that we used to hear from our customers is the failover, milliseconds failover, or like, what about if compute node fails? Can I actually have my VNF up in few seconds or in sub-seconds? How do I actually recover failures in sub-seconds or again milliseconds? What about line rate? Actually today we see that if it's a 10 Gbps network card that we are using, I can only get say a certain amount of bandwidth, which is very less from their requirement point of view. They expect a near line bandwidth performance. So basically that's another requirement. We actually heard about this from quite a few customers wherever we went, and all these requirements actually flew back into the engineering team, and that's when the Helion Carrier Grade, it was already into development, and the Helion Carrier Grade started getting all these features into the product release. So typically the first demonstration that I had was on the OpenStack compute services, OpenStack services failover. Basically, one of the typical problems that we have seen is you actually deploy a platform, OpenStack platform, and give it to the customer, and the customer has already started getting his VMs, onboarded his VNFs, and then typically they see that one of the compute node goes down or the compute services are not running. Next week he comes and sees that the Nova compute services are not up, the Neutron services, some of the Neutron services on the controller or on the compute is not working. So this is a typical failure that we have seen. So the demonstration that I had was you just kill an OpenStack compute service, a Nova service, and you see that within seconds, probably around 10 seconds or less than 10 seconds, we'll have the service running back. So this will not have any impact to the running VMs already. So this is just to show that how resilient the platform itself is. So this is one of the feature that I wanted to demonstrate. This actually holds good for the rest of the services as well, whether your Neutron services or your Cinder services. That was one of the use case. So typically, we also actually see that the VM actually where the customer application is running is going down. So this is the second use case that I'm talking about. So for various reasons, the VM actually gets killed. Probably the compute node running itself is killed. So the VM process is killed, and what the customer expects is there should be a way to detect the failure first at the first place, and then there should also be a way to actually auto-recover and self-heal and bring up the VM on on another compute node or the same compute node based on the type of failure. So here the demo that we had was the VM is running as a process on your KVM hypervisor. So we actually just go to the compute node where the VM is running and then kill the process. So basically we kill the process, which is the VM, which is running. And we see that the controller node detects the failure. And then your VM is actually brought up. Again, probably it takes not more than 5 to 10 seconds. Your VM is brought up within 10 seconds on the same compute node. So as a different process, you can actually make out that it's running as a different process. That's the second that's the second demo that we had. This is again to demonstrate that you're running a VNF which actually consists of various virtual machines, which is performing various functions. If one of the virtual machines goes down, probably within within seconds, actually you have VM up and running and your services are back. The third one in the list that I had was about live VM migration. I think this is a typical requirement. Again, we have heard. Most of the requirement, the customer experience comes from their VMware vMotion experience. So they say that actually we are used to a vMotion migration, live migration. Can OpenStack provide this today? This was a question that was asked almost a year back. Actually, we didn't have an answer then, but then in April this year, actually, when we had our Carrier Grade version released, so we did actually have the live migration feature available to demonstrate. In this use case, what we have is you basically have your compute. So this can be demonstrated through your Horizon dashboard. You don't have to actually do anything at the console level. So you actually have a VM running on, say, compute node 1, and then you go to the Horizon dashboard, and then you have a feature where you can actually do a cold migration or a live migration. So you go to the Horizon dashboard and do a live migrate, and then let the controller decide automatically which host it has to select for scheduling the VM to migrate to. You see that, again, this happens probably within less than 5 seconds. The demo, actually, if I wish I could show you the demo. The live migration happens within 5 seconds. You have the VM migrated within 5 seconds onto another compute node which is available. So this again can be configured to actually have what availability zones you have and where do you want to migrate to. All those things can be defined and configured. So before I actually proceed to the next use cases, if there is anything that you want to ask, probably I'll just give a small pause. Okay. So the fourth one is about the line rate, the near line bandwidth requirement. In most of our POCs, actually we were using a 10G NIC cards. So the kind of rates that we were seeing with in the absence of AVS, before Carrier Grade Openstack, we were using Open vSwitch, and the virtual machines which were using the VART-IO running on Open vSwitch used to perform the VM to VM communication between compute node 1 and compute node 2 used to be around 1 Gbps, roughly around 1 Gbps. So that was the speed that we could see, and with tuning, this again depends upon the customer kind of packets that they're sending, the size of the packets, the frequency of the packets, the bandwidth that they're going to consume. So typically, if the packets are very small, then I think if your packets are small, you might actually expect a better performance, but there will be a lot of packet losses. But if your packet sizes are huge enough, I think then your packet losses will be less, but you'll actually see a slightly moderate performance. This is again before Carrier Grade Openstack that I'm talking about. So now when we actually talk about AVS, within accelerated virtual switch is nothing but on the compute node where you're going to host your virtual machines, you have the DPDK enabled AVS. This is actually the switches, the virtual switches which are enabled with the DPDK capability. This is on the hypervisor. This is on the compute node which is hosting your virtual machines. So on the virtual machines, you have multiple options to run with. So one is you have a VART-IO. You actually have a virtual machine which can be run as a VART-IO, as in the previous case, or you can have a virtual machines run with an AVP, which is called as an accelerated virtual port. What it means is your guest image is also compiled to run with DPDK libraries, and your application can take the complete benefit of the accelerated virtual port at the guest level and the accelerated virtual switch at the host level. The difference that we have seen with the VM running AVP and AVS is almost 9 times. So if it was running at 1 Gbps in the earlier case, it actually run at around 9 Gbps per second, or even 9.5 Gbps per second. So that's the difference that we have seen with OVS and AVS and accelerated virtual ports. So this is how we assure that the customer can benefit the near line bandwidth requirement. A few other requirements is basically about scaling and scale out. This can be auto scaling feature. Basically, this can be configured to do an auto scale in, scale out, or auto scale up and scale down. So basically, your resources, your CPU resources or memory resources, you can define policies. You can define alarm thresholds and monitor it using ceilometer to scale up or scale down your resources automatically when it hits the threshold. This again, actually, we had a demo. We could have easily showed that when the CPU hits a certain threshold, say high threshold of 60% for a sustained period of 60 seconds, there's automatically there is a scaling up that happens wherein additional CPUs are added onto the VM, and then your average utilization comes down. So the last two use cases that I had was on the platform itself. All these things that we talked about actually was from a performance point of view, from a service availability point of view, from a VM availability point of view, VM recovery point of view. The last two was more on the platform itself, wherein what if your compute node fails over. So basically, all the VMs which were running today on the compute node 1, say, which is failed over, should be immediately brought on to another compute node 2 with the data. In this case, we need to have a shared data where all your application data is running on a shared storage. And there is also a memory copy that actually happens from a compute node 1 to the compute node 2 where it's being failed over onto. And the last one is about the controllers. So basically, HP Helion provides a multi-controller solution wherein you have redundant controllers available to take care of active controller failover. If one of the controller fails over, you already have the other two controllers up and running, and basically the ownership of the controller moves on from the active controller to the standby controller, and all your services are up and running as usual. So that was the last use case that I had for today. So if anyone is interested, to really actually look at the system, probably we can show all these demonstrations. It should take around 10 minutes. If you want to stay back and look at the system, we'll be more than happy to show you these use cases. Thank you.